In this video, we'll look at a polynomial function and determine its leading coefficient, degree, and then use that information to find the end behavior of the graph of the function. We're given f of x equals 2x cubed plus 2x squared minus 24x. This is a polynomial function that's written in standard form. So the first term, 2x cubed, is a term that has the largest exponent, and therefore that number on the exponent is the degree of the function. So the degree of this polynomial function is 3. The coefficient of that term is the leading coefficient, which in this case is 2. So we have an example of an odd degree polynomial function with a leading coefficient that is positive. Knowing these two pieces of information, we know the end behavior of the graph of this polynomial function. An odd degree function has to do opposite things at its ends, and if it is a positive leading coefficient, it's going to have to end going up. And so we know that at the right it's going to go up, but at the left it has to go down, or in the opposite direction. So our end behavior is this. As x goes to infinity, y goes to infinity. That's the same thing as saying it goes up to the right. And as x goes to negative infinity, y goes to negative infinity. So that is the same thing as saying it goes down to the left. The simplest example of this is y equals x. Do you recall that is a line whose slope is 1 with a y-intercept of 0? And we know that it looks like this. A line that goes through the origin, going up 1 over 1. And notice that it goes up to the right and down to the left. When we generalize this to polynomial functions with odd degrees and a positive leading coefficient, it's going to behave the same way at its ends. Now, we want to keep working with this particular function, and we want to now find the zeros and their multiplicity. So we have 2x cubed plus 2x squared minus 24x is our function. To find the zeros means to find where f of x is equal to 0. That is, when we set that function equal to 0, what are the solutions? First, observe that there's a common factor of 2x. When we divide out by 2x, we get x squared plus x minus 12. So we have 2x times x squared plus x minus 12 equals 0. The trinomial factors further. We need the factors of negative 12, whose sum is 1. And if you recall, that would be a 4 plus 4 and a minus 3. And so when we set each of those factors equal to 0, we're going to get that 2x equals 0, or dividing by 2 gives us x is equal to 0, or x plus 4 equals 0, which gives us x equals negative 4, and x minus 3 is equal to 0, gives us 3. So our zeros in numerical order are negative 4, 0, and 3. Notice that each of those factors is raised to an exponent of 1 in the factored form, so the multiplicity of each of these is just simply 1. If we have an odd multiplicity at the 0 on the graph will cross the axis there. If it is an even multiplicity, it's going to bounce off the x-axis at that particular 0. So now we're going to put all of these things together to think about graphing. So we have, again, f of x equals 2x cubed plus 2x squared minus 24x. On the previous slide, we just learned that our zeros were negative 4, 0, and 3. So that corresponds to our x-intercepts of negative 4, 0, 0, 0, and 3, 0. Our y-intercept is found by replacing x with 0. But if we substitute 0 into the function everywhere we see the x, we're just going to get 0. Now the maximum number of turning points, that refers to if I know the degree is 3, how many times can the function turn? How many times can the graph of the function turn? And that's always going to be 1 less than the degree. So if the degree is 3, our maximum number of turning points is 3 minus 1, which is 2. Now the domain of a polynomial function is all real numbers, or negative infinity to infinity. The range, it does depend on what the degree is, but because the degree is odd, it's going to go up on one end and down on the other end. It's actually going to be all real numbers as well, and we'll see that in just a moment. Now to answer the other questions, we're going to have to use our calculator, but let's think about what the graph of this would look like first. We're going to plot our intercepts, which are at -4, 0, 0, 0, and 3, 0. We know our y-intercept is also at 0, 0, which we have plotted. Now the thing that we know is that it has to cross the axis at each of these zeros. We also know that as we go to the right, the graph is going to go up. And as we go to the left, the graph is going to go down. So we can actually sketch the graph just knowing that information, because I know that it's got to go through the axis at -4. So it started below it, then it's got to go through it to some high point, and then it's got to come back down to go to the 0, 0, but it has to cross the axis there. Then it's going to have to go down to some point and then turn back up to go through the axis at 3, 0. Now those points are not precise. To get very precise, I have to use my calculator. So let me turn on the calculator and we'll use that to find the rest of the information.